have a fairly intriguing looking equation here. It's a fractional equation, and it's actually one equation and two unknowns. Now, it's kind of surprising that this can be solved because, again, we just have one equation, and yet we have two unknowns, x and y. And just like many of the things, there's a special result that kind of relates to the structure of this that makes this thing tick. Now, let's move on and take a look at the solution. Okay, now, so I've rewritten the equation up here. Now, there's a result here, and this is kind of fun. I proved this in a recent video, but if you'll take a look at this structure right here, we have 2 over k equals 1 over n plus 1 over n, which is the same, look as this equation right here. So you can see right off that 52 would be your n in this equation. Y, of course, would be m, and then x would be k. Now, again, by a process referred to as completing the product, not completing the square, we can actually write m and n, these two denominators on the right-hand side, m and n, as functions of the denominator on the left-hand side. In other words, we can write m as a function of k and n as a function of k. Now, it is assumed that m is a natural number. These are all natural numbers here. K, m, and n are natural numbers. And it's assumed without loss of generality that m is strictly greater than n. And you can see that m is a bigger number than n just by appearance here. So this, if you trust this result, which really takes maybe about a couple of minutes to prove, you get the answer fairly rapidly. If you set 52 equal to x plus 1 over 2, you get x equals 103, which turns out to be a prime. Now, this result holds whether k is prime or not, but we did happen to get x equal prime here, 103. And this expression does have a unique right-hand side in the event that k is prime. Now, in a similar fashion, if you substitute the 103 in into this piece right here, you're going to get this massively large number. Okay, but so we have our solution. The solution is x equal 103 and y equals 5356. And again, it's kind of cheating because unless you have a result like this, there's no way you're going to get to first base with one equation and two unknowns here. Now, just to show you how the uniqueness really is significant here, I want to back up a little bit. Let's see. Where can we go here? Now, notice right here, we have the same looking sort of thing. We have 2 over a number, but notice that 15 right here is a composite number. It's a composite number, so it actually has 2 different representations. See, 15 is not prime, and it's at least 2. There may be another one. These are just 2 that I found. So you may want to go back and look at the proof for completing the product to see why this works, but it's essentially true because p squared only has 2 pairs of factors, namely p times p and p squared times 1. If for a composite here, you're going to have a lot more divisors other than just p times p and p squared times 1. And again, I refer you back to that last video if you want to look at how that goes. But again here, 2 over 15 has 2 different representations as 1 over some natural number as compared to the solution right here where we found out that k was actually a prime number, 103. This is the only solution to this equation. Okay, hope you guys enjoy.